Hi everyone, Mr. Neighbor here, and today we're going to talk about scientific notation. Scientific notation deals with powers of 10. So you will see things frequently like this. A number times 10 to some power. A number times 10 to some power. And just remember, 10 to that power just means you're taking 10 times itself this many times. So 10 times itself twice, which would be 100. 10 times itself 3 times, which would be 1,000. 10 times itself 6 times. So it has 6 zeros after this 1, and that's what you're doing. All right, so how do you use scientific notation? It's used to reduce the number of zeros in a very large or very small numbers. And to show the level of precision, you can express the values as simple numbers multiplied by a power of 10. So your coefficient is always going to be a number between 1 and 10. It's not going to be 10. It's going to be a number less than 10, but it could be the number 1. If it was more than 10, then we're going to change the exponent. So positive exponents are for large numbers. Negative exponents are for small numbers. And this is always the base. 10 is always the base. So here's some practice. The speed of light is 300 million meters per second. Express this in scientific notation. So what I like to do is put my decimal point where I know it has to be. So the number 3 is the number between 1 and 10, which the coefficient needs to be. And how do I get it from there to be here? So I have to move it once, twice, 3, 4, 5, 6, 7, 8 times. So that means I have to multiply by 10 to the 8th power. So I write 3 point times 10 to the 8th power. I don't actually need that point there. A certain bacterium is 2 times 10 to the negative 9 meters long. Express this in standard notation, meaning just a number with a bunch of zeros. So what I like to do for this one is I like to write my number with the decimal point. The negative means I have to make this into a small number. So I move the decimal point in the direction that will make it into a small number. This way would make it big, so I move it this way 9 times to make it small. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where my new decimal point is. Put my leading 0 in, and then all the other zeros in these little valleys. A neat trick, there should be 9 zeros including this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there you go. And then here we have the last one. We're going to add these two numbers together. So this is a little tricky. What I suggest to a lot of people is just write out what the number actually is. So this has to move 4 times to the right. So it's really the number 14,000. And then add it to what this number really is, moving this decimal 3 times, 7,800. And then you always can find the answer and put it back into scientific notation. If you didn't want to do that, you kind of have to think about it. Normally, you would line numbers up like 1.4 and then have 7.8 below it. But remember, this has some zeros after it that you aren't seeing. This also has some zeros after it, but not as many. So it's going to be closer to the edge. So you would have to add it like this, which is kind of hard for some people to think about. So that's why I don't always recommend doing this. So 218, and the decimal point would go right there, lining up with the biggest one. So it's 2.18. And since it lined up exactly with this bigger number, it has the exact same number of powers of 10. So it's whatever the powers of 10 it was for the 1.4. So it's 10 to the 4th, which is what it has here too. More practice. Again, a subtraction problem. I would probably go ahead and write out what this number actually is. 4.3, move it 7 times. 1, 2, 3, 4, 5, 6, 7, minus, and then move it 6 times. 1, 2, 3, 4, 5, 6, and then subtract them. If you wanted to do the quicker way, it'd be 4.3. There's a bunch of zeros after that. And then 2.1 doesn't have as many. It has one less zero, so it'd line up like that. And then you would just do your subtraction. You get out 409 times 10 to the 7th either way. Here's another one. So writing those out, it would be 0.00032 plus 0.00028, and then add them and then put it back into scientific notation after you added it together. Or if you wanted to do it like this, this one's trickier. So I would have to write out 3.2. Now that has 4 zeros going this way. Then 2.8 has 5 zeros going that way. So those zeros are actually pushing it further this way. So I would be adding it like this. So 8, 4, 3, and I take the power of 10 that goes with the 3, 0.2, which is 10 to the negative 4. So this answer would be 3.48 times 10 to the negative 4th, which is what it has right here. But it's okay to do it like this. What I really, really like is when we have powers of scientific notation and they're multiplied. These are really slick. A lot of times you'll see these problems with parentheses kind of separating them so you don't get this multiplication sign confused with this one. But essentially, multiply these two numbers together and then add their powers of 10. So this would come out to be 3.6 times 5.84 would give you 21.0. And then adding the powers of 10 would give you times 10 to the 5th. But there's a problem. 21, bigger than 10. Remember, our coefficient has to be between 1 and 10. So for that reason, we have to move this decimal point once right here. So if I move it once to the left, that would give me out the number 2.10. And what power do I need to make this number still be the same? I was going to move 5 times this way, but now I'm right here. So in order to end in the same spot, I have to move the decimal point 6 times. So multiplication, that's one that we really should be working on doing. Maybe not in our heads, but we can do 3.6 times 5.84 with a shortcut. So I would recommend doing that. Here are a few more problems. 8.1 times 10 to the 12th divided by 7.6 times 10 to the 14th. Just like multiplication, division, you can divide 8.1 by 7.6, and you would get out the number 1.07. And instead of adding the powers now, we would subtract them. So then you get out negative 2. But again, you can write out this entire number if you want, moving the decimal point 12 times, and this one 14. That's perfectly fine. Last one, you can do the same thing. 6.4 times 10 to the 6th divided by 7.6 times 10 to the negative 4th. Just divide 6.4 and 7.6, and you would get out, one moment, you get out 0.8421, and then there's even some more numbers after that. So this is an approximation. And then divide means subtract their powers. So 6 minus negative 4 would be positive 10. But problem, this number is smaller than 1. It has to be bigger than 1. So I really have to write this number as 8.421 times 10. That decimal point was right here, and I moved it over there. So I have to move this decimal 10 times to the right. But I already kind of have it moved once for me. So that means I still have to move it 9 more times. So here's a way just to kind of do that part in your head. Our last thing I want to show you is how you can actually enter scientific notation into your calculator. So let's say we're trying to put this number into our calculator. You would do 8.42. You could, instead of doing the times 10 to the negative 9th, do the EE feature. And then it would just be the number 9. This essentially means times 10 to the, and then you just type the 9. So that's under the comma button when you want to use it. It's under the comma button. This says So go ahead and try that when you want to type in scientific.